Hello everyone, and welcome to Science Cafe for November 16th, 2020. For tonight we're going to talk about a couple of Mars missions. One is the Viking mission that happened in 1975, and the other one is Perseverance, which is on its way to Mars right now. To assist me with this presentation tonight, I have my daughter Serena here. Serena is an alum of many STEM workshops during the summer, and she has a great interest in space travel. I don't know where she got that, but she certainly does. She's so fascinated by space travel that when we went to Huntsville to the U.S. Space and Rocket Center, that we bought her a American Girl doll named Luciana, which was the doll of the year. And if you can show the that particular doll actually was supposed to be heading to Mars in the story. So anyway, we'll go on with everything that we're talking about. We're actually using some models tonight to talk about the spacecraft. We didn't have the time or the budget to build the real size things, so we went with about a 1/20th scale model. The other reason for not building a full-size model is that that would fill up our garage, and I've just now cleaned out the garage, and so my wife is happy about that, and she would not be happy if Curiosity or Viking was sitting in that garage. So a couple of disclaimers here, and that obviously this is not real Mars soil. It's as close as we could get today, and this is something that, in terms of modeling things, this is a nice way to spend a couple of evenings to put something together. So this is actually something that you can do at home, rather than being advised not to. So let's take a look at Viking, and I've always thought that it was interesting that we named this particular spacecraft Viking. I mean, we have really nice, peaceful names now that we use in terms of Pathfinder and Curiosity and Perseverance. And in fact, this particular mission was preceded by the Mariner missions. But for some reason, we named this one here Viking. And it's interesting in terms of, if you do an internet search for Viking lander, the first thing that you'll find out is, or that you'll see, is a longboat full of warriors. Or you'll see an advertisement for Viking Cruise Lines. So this mission happened long enough ago that a lot of people have forgotten about it. But it's really important in terms of space flight, and many of the things that happened with Viking we're seeing today in terms of both Curiosity and Perseverance. So I'll talk a little bit about this. And this is a Viking lander. I'm just going to do kind of a slow move around here so that you can see all the different features of it. And Viking was our first mission to land on another planet. It's not the world's first mission, because the Russians had one that landed about a year ahead of this one. Theirs transmitted for about 45 seconds and then went quiet. This one here, actually, this is Viking 1, supposed to be, and it actually transmitted until 1982, and probably would have transmitted a lot longer, but someone sent the wrong command to it and it shut down. So that's how it goes. But there's some things here. I mean, first I'll talk about how it actually got to Mars. It took almost a year to get there, because the launch technology that they used in 1975 and the heavier payload just took a little bit longer than normal to get that mission there. We had preceded the mission with the Mariner missions. Mariner were two orbiters that collected information about Mars, and so this is our first attempt at landing on another planet. Interestingly, today we're so familiar with rovers. At that time, the only rover that we had any knowledge of was this one, the LRV. that they used on missions Apollo 15 through Apollo 17. And of course, this was a manned rover. The Soviet Union had landed a robotic rover on the moon, but that was still, we didn't have any experience in terms of the United States in terms of sending a rover to Mars in 1975. We had a lot of experience in terms of landing rovers on, or not rovers, but landers on other bodies, because we had landed Surveyor on the moon prior to the Apollo missions. And this configuration in terms of how the lander is built is pretty similar to Surveyor, because there's 3 legs and then a hollow body, and then the payload that's actually sitting on top of the body. Just like today, the rovers that we know about, Curiosity and Perseverance, use something called an RTG to power the missions. That stands for radioisotope thermal generator, and Viking used the same type of power generation, and it actually had NiCad batteries on board to store electricity. So some things just never change. Viking's mission was to do biological and chemical analysis of Mars. And coincidentally, Perseverance has that same mission. So let's talk a little bit about the landing. Viking was the first lander to use an aeroshell design. And I just happen to have a little miniature Apollo capsule here with little miniature astronauts rocking back and forth in there, wondering what's happening to them. And so Viking came down like this, had a heat shield, actually was sitting inside of this aeroshell, reached a certain point, the aeroshell parachutes deployed, slowed everything down, and then the aeroshell went away, and the lander came down the rest of the way using small rockets. We use the same type of technology today in terms of Perseverance, and except that we use something called the sky crane maneuver, which makes it a little bit safer. They were able to control a good landing for Viking 1 and Viking 2, but in terms of technology, we've made some advancements. So the cool thing about this, I'll turn this around again, in that there are actually 3 rocket bells. You can see one right here, another one right here, and the third one right over here. Now, if you look at that, you think, well, it's just got 3 engines and it's going to, set down like any normal rocket. But they actually built 18 small rockets into each housing. And the idea behind that was that they did not want to stir up a lot of Martian dust with the landing. And so I was unable to duplicate 18 miniature rockets so far in terms of the scale that we're using. But if you can imagine, there would be 18 rockets sitting here, and those prevented the dust from coming up. In my zeal in terms of building a model, I actually put some red dust on this so that it would look a little bit realistic. There's also some rocket engines right here. These were the engines that they used for to actually slow things down, and then the main ones took over. You'll notice here that Viking has 2 fuel tanks. There's one here and one here. The actual RTGs are sitting right up in here in terms of the power for the lander. I've always loved this particular model just because this looks like something that maybe one of us could build in our spare time, because if you look at the real Viking, I mean, there's bolts showing, and there's all these instruments that are just sticking out here, just like something that we might build in our shop. In terms of communicating, there was actually another part to the Viking mission which I did not build, and because I wanted to concentrate on the lander. But the other part of Viking was orbiting Mars. And so there's a couple of different types of antennas on here that they use to communicate. This larger dish antenna was used for direct communications with Earth. But as we go around here, there's some smaller antennas. There's one right here, and another one right over here. These are little bitty UHF antennas. And the idea was that that would allow it to communicate with the orbiter. So it's really kind of neat looking in terms of the way that it was built. And there's actually another antenna right down under here. I don't know if you can see it in terms of the camera or not, but again, used to communicate with the orbiter and also provide some ground radar for the landing. Now, Viking had 2 cameras, and this is a little bit of a unique setup in terms of how the orbiter, or not the orbiter, but the lander worked, because we have a camera right here, and we have another camera right over here. They had a system of mirrors that they used to focus the cameras on the Mars landscape, and this is Viking provided the first images of Mars that we saw, and so that was a real cool thing in terms of what that mission did. But they could rotate these cameras a little bit back and forth so they could get a panoramic view of the landscape. And then a little bit limited, but some of the images that we have from Viking are really, really fantastic. Now, Viking, one of the most prominent features is the arm. And, today we're so fortunate to have a lot of different types of robotics. This arm is going to seem a little bit archaic in that it was not articulated. It was basically retractable and extendable. So they could swing the arm around just a little bit, and then they could extend it down or extend it out. And there's not only a shovel in the arm, but there's also a temperature sensor and also some magnetic sensors to see if there was any type of iron ore or anything in the surface of Mars. Just turn this a little bit more here. Viking had a couple of different experimental packages on this. One right here is for biology experiments, and another one right over here is for chemical experiments. So they're really trying to do some analysis of both the atmosphere and also the soils in terms of Mars. And I'll turn this around a little bit more. There's a seismograph over on this side right here that, according to some of the different articles I read, NASA kind of threw that seismograph in there at the last minute. I'm not sure if I really buy that or not. But this seismograph was sitting up on top of the lander, and one of the things that they ran into in that they could not get accurate measurements with it because of the Martian winds. And the seismograph actually failed pretty quickly after the lander was operational. So I'll turn this around some more. And there are some other transmitting antennas up here in terms of, right here is another one talking with the lander. And the interesting thing is that the entire base of the lander is just hollow. Now, there's a lot of debate in terms of what Viking accomplished. And the early results were that it really didn't accomplish much. I mean, it had all kinds of sensors in there in terms of meteorology, and there's a boom right here, and they were measuring the current to see if there was any, what type of weather activity that they were seeing on Mars and that type of thing. It wasn't the most sophisticated meteorological setup, but it was still, for that time, pretty good. Their idea was that they could measure wind velocity and wind direction with this boom sticking up here. But when they did a chemical analysis using all the Viking instrumentation, the results were a little bit uncertain, and they just were not sure of what they were seeing. There was a toxic chemical that was discovered by Viking, and the conclusion at that time was that Viking probably, wasn't as sterile as they thought that it was, and that it had introduced a chemical into the Martian atmosphere. And so that soil analysis was considered to be flawed. Now, as late as 2006, they were still doing analysis on what Viking provided in terms of the results. And they think that actually the chemicals that Viking uncovered might have been the first signs of life. And I can't remember the exact name of the chemical. I'm not even sure if I can pronounce it, but that particular chemical is considered to be a byproduct of life, and that's not something that they really thought about, in 1975. So I'll continue kind of moving around here. They had a mass spectrometer in this. They also had a gas chromatograph, and the idea was, again, doing measurements of the atmosphere and the soil. Trying to think if there's anything else here in terms of, if I turn this around a little bit more, you can see some of the battery supplies as well on the lander. Interesting thing about Viking in that it was actually launched so that it would land on July 4th, 1976. This is supposed to be a bicentennial celebration. Because the payload was a little bit heavier, they missed that date, and it actually landed on the anniversary of the first moon landing, July 20th. And so that was pretty cool. I mean, when I first thought about the bicentennial thing, and I haven't had a chance to apply the bicentennial decals yet, but I thought, well, it would have been pretty cool if an American flag would have popped up out of the lander or not, but maybe not. So anyway, this is supposed to be a celebration of our bicentennial as well as the first landing on Mars. Let me see if there's anything else here. As I mentioned, Viking transmitted for a very long time, 1982, and then of course there was a Viking 2. If we were looking at Mars in terms of kind of a global view, Viking would be over in the right-hand upper quadrant of Mars. The rovers are down a little bit further in terms of how the planet, if you're looking at the planet head-on. I really think that it's interesting that the idea that it might have found life, this mission was also the first one that we really put together in terms of the biological and the chemistry experiments. And we've sent other missions to Mars in terms of Pathfinder and Curiosity and of course Perseverance. Perseverance is really the first one since Viking to do an extensive test to see if life exists there. One thing that I'll mention also is that, and I don't know if you can see it on the model or not, they used an extensive amount of insulating blankets on the lander. You can kind of see it here if you look at the fuel tank. They were very unsure in terms of the technology if it would survive Mars. And so they used all the means that they had at the time to protect the instrumentation and of course the fuel tanks. Now, one thing that we'll do as we transition over into talking about Curiosity, we'll take a short break so that we can change out the models because we have another one to show. Serena, did you have any questions or anything about the lander that you wanted to ask?
I think you answered them all for me.
Okay. So let's take just a short break, about a minute, and I'm going to get up and change out the models, and then we'll bring Curiosity in and set this up. And if anybody has any questions, we'll certainly try to answer those as we can. So let's take a quick break here, and then we'll change things out. Yeah. Bring it.
Okay. Questions or all things over there. So.
Okay, so we're back, and we've changed out our models in terms of moving away from Viking and bringing Perseverance up. And this model of Perseverance is a little bit different in terms of scale than the Viking. Viking was about, probably about 10 feet square. Perseverance is just a little bit larger than that. It's about the size of a good-sized car, and but the comparison of the two is pretty good. So I'm going to give just a quick turnaround here. In terms of how this looks. And I know that we've had some questions come in terms of Viking, but we're a little bit delayed in seeing those questions, so I'll try to answer those as we can. Okay.
Okay. Okay. Many mission goals of Perseverance will be to look for signs of ancient microbacterial life, collect Martian rock and dust samples for later return to Earth, and deliver an experimental helicopter. It will also study the climate and geology of Mars. demonstrate technology for future Mars missions.
I'm sorry, Serena, I threw you a little bit of a curve there. I know that Paul had a question in terms of how did the instrumentation of Viking influence what we're doing today, and a lot of the same experiments are kind of really surfacing in terms of Perseverance, the spectrometry and the measure of gases and the measure of soil types is all very much prevalent in terms of what Perseverance does, and really building off of what Viking found for us. So in terms of what Perseverance does in terms of its power supply, again, it has that RTG sitting back in here. A little bit more of a robust unit in terms of what Viking had, but still, kind of the same principle.
The Perseverance mission will last for 687 days, or 1 Mars year, because it takes longer for Mars to go around the Sun. NASA does have a good track record with extending their Mars missions, which you can see with the other ones that they've done. The Perseverance rover will collect about 20 samples with its robotic arm, handy drill, that's right there, that's attached to the arm. The rock samples will be stored away in test tubes and will be picked up by future missions. Another fun fact is the names of 10,909,032 people were etched onto Perseverance as part of NASA's Send Your Mars campaign.
So Serena, do you know how many cameras Curiosity or Perseverance has on it? Just kind of curious here. The reason I asked that in terms of Viking, we know that it had 2 cameras, and that those were a little bit of maybe a little bit more of a primitive design. Perseverance has 23 cameras on it, and as we turn it around, there's 4 cameras sitting down here at the bottom of it. There's cameras up here, and I guess what we can call the face of Perseverance, and there's also cameras back here in terms of rear facing. So that's, to me, quite interesting that it would have all those cameras on board of it. And in terms of rock samples, how is it getting to all those rock samples? Do you know? If you look right here, there's this turret is a lot more complicated than anything that we've seen in terms of a Curiosity. There's drills right in here, so you can see that the cameras up here will aim over at the mark. There's cameras down here that are focusing here, and this robotic arm can lower this drill down to the surface and then take the core samples. And that's really a bit of a takeoff in terms of what Viking did with that retractable, extendable arm, in that it could dig and it could do some analysis. This is a much, much more sophisticated way of doing it here. One thing that I did not point out to Serena as I built the model was that there's actually a little sampling area right here, and I'll turn this around so that you can see it. So we have the drill, the turret with all the instrumentation in it, and then we have the sampling unit right there. So what are they going to do with the rock samples, Serena?
They are stored in test tubes, and they'll be picked up in Mars missions that they're going to be doing in the future.
So that's really quite interesting to me that they would just store rock core samples on the surface of Mars. That's a little bit different than what we saw with Viking, isn't it?
Viking.
I mean, there was not really a chance to go back and pick up Viking and look at those samples or bring them back to Earth. The analysis was just done right there on the spot. One of the other cool things about Perseverance is something about oxygen. Do you know what that is?
It is the first test of producing oxygen from Mars's carbon dioxide atmosphere, which is a necessary step for sending humans to Mars. So it sort of paves the way for us to go to Mars someday. It is also necessary for rocket fuel to have oxygen.
Now, we talked a little bit in terms of what how Viking landed, and that they used the aeroshell design, and that it was radar guided, but it was a little bit hit and miss. In terms of what Perseverance is doing, it has a landing center, and that will actually steer it away from any obstacles as it's landing. But it also has cameras and microphones turned on so that it can record not only the video of it landing, but also the audio. So that's a little bit different in terms of what we've seen in the past. One thing that is really cool about Perseverance as well, it's almost like we've taken Curiosity and we've traded it in for a new, much better model. This has internal heat pumps, and the idea is that it keeps the rover warm and it keeps the motors warm so that the head and the wheels can turn much more easily. Another thing about the way that the treads are made on this, in that for Curiosity we had treads that were kind of at an angle. They did some tests in terms of JPL, and they found out that the straight treads on Perseverance gave it much better traction. And so Perseverance looks similar to Curiosity, but it's a lot different, and it's like getting that new model. How fast does this go? Do you know, Serena?
It can go just under 0.1 miles per hour, which is 152 meters per hour.
Doesn't seem very fast, does it?
No.
No. But we're really not out here to break speed records. We're out here to explore, and so that's an interesting thing in terms of sometimes we watch videos of these things and we think that they're moving really fast. It's actually quite slow. So, Serena, if you can tell me a little bit about the scientific instruments on here, and then we'll see if we can relate it back to Viking a little bit. I guess if you want to start with the head here.
The head is the Mastercam Z, which is a zoomable panoramic camera that will take high quality videos and images of Mars.
Viking, in terms of its cameras, were it was pretty crude because I used the mirror system, and they had actually painted on the lander some symbols so that they could focus the cameras. With this camera, is it any better than that?
Yes.
Can you zoom with it or anything?
It is zoomable.
Okay. One thing that's quite very cool in terms of how this lander is made, and this is a takeoff from Curiosity, is that, of course, the head can tilt, it can rotate, it can move down a little bit like that, and so it's very much in terms of getting that good view, and it's also helps with the autonomy of the rover as it moves across the surface. we talked a little bit in terms of Viking that it had a spectrometer on board. Perseverance actually has a couple of different types. There's an ultraviolet spectrometer up here. Let's see if I can pronounce all that correctly. There's also an X-ray spectrometer in the turret as well. Anything else about that camera in terms of how does it target? How does it focus?
It has a laser.
Oh, really? Okay. Again, moving this around, and sometimes we hope that you can see all the details here. What's this thing right here, Serena? I think that that's actually a weather station. And is there a
Yes.
name that they gave that? It's called
MEDA.
Okay. And there's something else that's really, I think, pretty unique to Perseverance in terms of oxygen. Do you know what that is?
Moxie, which is, let's see if I can find it on your model, produces oxygen from carbon dioxide. Moxie is short for the Mars Oxygen In situ Resource Utilization Experiment.
That's pretty cool. Again, kind of looking back at the mast cam up here, is there anything special about that? You know, when we looked at Viking, that gave us the first images of Mars. How is this one different?
It can take videos, it can zoom, it's panoramic, and it's much higher quality. And it can also take 3D images and with that.
3D images, that's pretty cool. In terms of high definition, do you think that that will help in terms of scientific analysis?
Yes.
And there's a particular landing spot for Perseverance, and do you know why they picked a certain spot in terms of the crater that it landed in?
Not exactly.
Does it have anything to do with maybe water under the surface, or
They do believe
potential?
there could be water there, or there at least was water there.
So, you know, we send these rovers and we send landers to Mars, basically with the idea that at some point that humans are going to go to Mars, and it may be, you know, somebody that's sitting right next to me may be one of the first astronauts to go to Mars. We never know, but there's something on Perseverance called Moxie. Do you know what that is?
It does talk about this a little bit before. It is the Mars Oxygen Institute Resource Utilization Instrument. It's Perseverance's way of helping to prepare humans to go to Mars. The instrument is designed to make oxygen from the carbon dioxide that is already in the Mars atmosphere. This is a capability that will be very necessary to send humans to Mars. It will also help us make propellant for rockets on site.
Why do we need propellants?
To send the samples that we collected before.
Okay. So you think when we send humans to Mars, they might want to come back, right? Oh, okay. The whole idea behind Perseverance is to find signs of life. You know, and that was really the idea behind Viking and the different instruments that are on there in terms of chemical and biological analysis. And of course, the results were a little bit inconsequential with Viking. is there anything different about how Perseverance is going to work here in terms of how it looks for life? Is it better, or do you think it's about the same as Viking?
It is better. Using Sherlock, which is the scamming habitable environments with running and moving in a sense for organics and chemicals, as the instrument is affectionately known as Sherlock. It will search for signs of life on the planet. This instrument and its companion camera, which is named Watson, it's capable of taking microscopic images of Mars and using its own artificial intelligence to analyze them. Equipped with a laser, it can fire at rocks on the surface. Sherlock is able to measure chemicals.
So, if we look at it in terms of Viking, it's the same idea that we saw in terms of those experiments, but just much more sophisticated in the way we go about it. That ability to pinpoint samples and to take microscopic images is really something that's quite neat here, and it's something that we could not do, back in 1975. But the basic experiments, the basic purpose of experiments, let me say, is the same. Let me click on something here. Let's see if we're getting any questions or anything of that nature. Okay.
Pretty sure.
Okay. So another neat thing is that this is going to fire lasers at the surface of Mars. And that's not something that we had on Viking at all.
Yeah.
We just didn't have the technology at all. And so even though Viking had that spectrometer on board and it could do some chemical analysis, the idea behind what Perseverance does is much better. And it's going to take us, it'll teach us a lot more about what Mars does and about the composition of Mars is what I'm trying to say. Is there anything else different about Perseverance?
Perseverance isn't going to Mars on its own. The Ingenuity helicopter will also go to Mars.
Well, so what's this deal about a helicopter?
The helicopter can pick up samples a bit farther from Perseverance without having the rover to go so far away. It also has the ability to fly a helicopter on a planet other than Earth for the first time ever.
Yeah, and that's one of the key things. I mean, this is an experiment in itself in terms of having a drone on board Perseverance. And there's not much of a way that I can show where that drone is going to fit. It's actually underneath here. And the mission in terms of flying the drone is actually pretty short. But it's just the idea of being able to fly something that has composite blades, dual rotating blades, and is pretty lightweight across the surface of Mars, even for a couple of minutes, is just amazing to me. And the fact that they call it Ingenuity, I think, is appropriate there. Now, one of the things that we saw with, we go clear all the way back to the LRV, is that these wheels kicked up a lot of dust, and of course the astronauts sometimes were driving it pretty fast, and they didn't wreck or anything, but in terms of kind of creating more dust than they needed, it certainly did that. When they redesigned the wheels for Perseverance, they made them a lot larger, and they also made the aluminum a little bit thicker than what we'd seen on Curiosity. Why do you think they did that?
I do believe that it made it more able to handle the wear and tear driving around on the Martian terrain. It'll make the wheels more able to stand out longer.
Okay. When we looked at Viking in terms of how it communicated with any orbiters or communicated with the Earth, we saw that large antenna on there, and then we saw the smaller UHF antennas. It was definitely kind of 1970s technology. If you look at, I'll turn this around a little bit, there's a little bitty microwave antenna right here for communicating, and then there's some other antennas over here. Again, you know, the technology is caught up a little bit in terms of how Perseverance was built. I'm going to turn this around so that you can see the RTG is sitting back here. You'll recall when we looked at Viking that the RTG was protected by blankets, and they weren't sure how it was going to withstand the harsh environment. You'll see here that the unit is kind of sitting out there in the open a little bit. Sorry that I'm rocking that as much as I am. Another thing that I'm going to point out to you in terms of how the suspension is made for Perseverance, we saw the same thing with Curiosity, but Perseverance is a little bit more of an upgrade. We can turn these wheels, we can also turn these wheels, but this is a rocker assembly, so it's not something that I can duplicate with this model, but this is will actually raise up, and if Perseverance is wanting to go over a boulder or something like, or if it's an uneven surface, it can actually rock and move this up over a boulder while these here stay on the opposite plane. So that's a little bit different there. I'm going to check real quick and see if we have any questions coming in, and we'll see if we can maybe even answer some of those questions. So let's, I'll take just a minute and check on that. Okay, so Paul is asking some questions here, and we have a few questions that are popping up. Do some of the cameras record outside of the visible light spectrum? Yes, they do. Let's see if we can. I have a question from Scott Roletter. What was the communication speed for data from the test being done from Viking? Let me recheck on that one. I have an answer on that. And of course, Paul has asked a question about how has the uncertain result of Viking guided development of the present instruments. I'll answer this question right away in terms of the chemicals that they found with Viking prompted a lot of research, and there was a realization that one type of chemical was not naturally occurring in the Martian environment. Let me rephrase that, in that it did naturally occur, and that this was something that they were not aware of at the time, and so they changed that. And let me check and see if I can give an answer in terms of Scott's question about the speed of a transmission here, and I know that I've got that in my notes. Be just a second here. In terms of transmitting back to Earth, Scott, 381 megahertz. It was a one-way relay to the orbiter. The data storage was on a 40 megabit tape recorder. The lander computer in itself had a 6,000 word memory, so not anything to write home about in terms of today's technology, but for then it was pretty good. See if we have any other questions here. Paul has asked about the expected mission time for this one, and I need to check on that particular.
For Perseverance?
Yeah.
687 days.
687 days. And is there any significance to that? Is that?
It is one Mars year. The reason it is longer than an Earth year is it takes Mars longer to orbit the Sun than Earth.
Okay.
Yes.
So, do you think it's just going to shut down after 687 days, or do you think it's going to keep going?
It's going to keep going.
I mean, our record in terms of supporting missions on Mars has been pretty good. And as I mentioned earlier with Viking, it would have maybe transmitted a lot longer except for a faulty command going up. So let's see if we have a. Paul asked another question: when will we be able to bring the rocks back from Mars? Well, it depends on a future mission. What are they going to do with those test tubes? Do they just does Perseverance carry those around, or what happens to those? I see that I threw Serena a little bit of a curve with that question. I believe that they're going to store those test tubes on the surface of Mars to be picked up at a later date. Let's see if we have any other questions here. And thanks to everyone for asking those, and we'll do everything that we can to give a pretty precise answer. The maneuverability of Perseverance is really amazing to me in terms of how they use the robotics and in terms of all the instrumentation that is in that turret. And Curiosity had the same type of design in terms of the turret, but Perseverance has a lot more going on there. And one thing that we were not able to point out is got distracted just for a second here. Same type of turret for Curiosity, but a lot more instrumentation going on in here in terms of the ability to do the core samples and also the other instruments that are in there. James Burke has asked, is Mars core still active? What do you think, Serena?
Yes.
I believe it is. And that's not an answer that I just have at the tip of my fingertips, but I'll see if I can find that for you. And I believe the answer is yes. But we like to be pretty good on those. Now, one thing is we're checking on some of these answers for you. There's a lot of really good sites in terms of learning about how Perseverance works. As I mentioned, we had some difficulty in finding out information about Viking, and had to do a lot of digging to find out what Viking did. But Perseverance, there's a number of sites that you can go to that NASA has put up, and they have a lot of 3D views in terms of the spacecraft and how it lands on Mars. the sky crane maneuver, and the shell and everything that it uses. And NASA has a site where if you want to look at the rover in 3D, it actually builds that for you. I'm going to go ahead and say what that URL is. It's mars.nasa.gov/mars2020/spacecraft/rover. And it will, in terms of the site, it actually sits there and builds that 3D view. So if there are no other questions, let me see if there's anything else is coming up here. Sean asked if I said that there was a code command that caused the failure on the Viking lander. And the Viking lander, Viking 1, was transmitting well around even into the 1980s. So it was doing well. It was a faulty code command that shut the unit down. And this is not the only time that that's happened in terms of landing spacecraft or putting orbiters up, where a certain amount of code will shut everything down. So they made a mistake, and Viking is still sitting there. Let's see if we have any other questions. So if there are no other questions, we'll go ahead and conclude the presentation. I want to thank Serena. This is her first time in terms of doing a presentation, and I think that it's really essential to introduce the next generation to doing this type of thing. I know that at some point she'll go to space camp, and who knows where she'll end.